Hello, hello. Welcome back. Today we're doing balanced binary tree. We're still in week one, still in the easies, and this is really good practice for the mediums and the hards. Okay, so balanced binary tree. Given a binary tree, so this is not a binary search tree, just binary tree. Determine if it is height balanced. Okay, this one is a link. So height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. Okay, interesting. So here in this example number one, you have this root node 3, 9, 20, and then 20 is balanced because the 15 and the 7th, so the 15 and the 7 have a balanced depth, and the 20, okay, and then the 9 and the 20 have a balanced depth. It does not differ by more than one. Right, so let's just draw this here. So this is a 3 here, the 9, the 20, the 15, and the 7. Now, if this, so this has depth 1, I guess, and this is depth 2. If this was, an 8 here, this would be depth 3. This would be, so the 8, so here at this point, it would be 3 versus 1, right? And then 3 minus 1 is 2, so then this would be unbalanced. Okay, and then for the example 2, actually, this is a perfect example. They have a 1 here, a 2 here, and this is the, let's call it the depth 1. They have a 3 and a 3. Let's call this depth 2. They have a 4 and a 4. Let's call this a depth 3. So what's being returned from these nodes, use a different color here. What's being returned from this node is that, sorry, depth and height are actually different. So it might be that this is D1, D2, and D3. And then the root would actually be a depth 4. I don't actually remember which way depth and root is, but I'd imagine this is height, right? Because how tall something is, and the opposite would be depth, right? So how deep something is. So maybe this would be depth, and this would be height. So a height balanced tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. I'd imagine because height and depth are completely oppositely correlated, it's the same. So when we're thinking about what to return out of this node, let's think about how to just return the value of the height, right? So we want this to return 1. We want this to return 2. This returning 1. We want this to return 3. And then this would return 1. And then at every node, we can make the comparison. What's coming from the left and what's coming from the right? And does that differ more than 1? Right. So the way that I think about solving this in many recursive problems where the purpose is to return upwards from the leaves is I would use the tree builder pattern that we introduced before, right? So I'm just going to write tree builder here, and the tree builder pattern is a pattern where we're going to rebuild the tree, right? Or at least traverse it from leaf up. So imagine you had a function and that function took a node. We might have a base case for that node, right? So it would be something like if node is none, then we do something, right? And then we have two cases where we're going to call it recursively from left, and we're going to call it recursively on the right, right? And that would be whatever go function that we have, node.left, and then whatever go function that we have, node.write. Sometimes you want the return value of this. You don't always want it. I'm just going to call this FL here and FR here. Right, so we're calling the recursive function on the left and the right. And what do we want from this recursive function? Let's bring back this little tree here. What do we want from this recursive function? Well, we want the height. And in our tree builder, we have this base case. We have the from left. We have from right. After we have from left and from right, we can do some logic. I'm just going to say logic here. I'm not going to do something, but the logic's probably going to take the FL. It's going to take the FR. It might even take the current node, right? So with all three of these, it's going to do some logic. And then we're going to return, right? And the return is always going to be some recursive. The return is going to be essentially this right here. What do we want to return? What is the logic that we're doing, right? And when we're doing height, if each one of these is a height, then we want to return 1 plus 1 plus the height of this node, which is actually, in certain situations, the maximum height of the left and the right node, right? So imagine we're here, right? Let's imagine we're calling this function on the 2, right? We want the height from this here, right? This part right here. We also want the height coming from the left side, whatever the left side height is, right? Here, coming from the left side is this 2, right? Because the height of this was a 1 right here. The height of this was also a 1, but at this point, it's a 2, right? I mean, you could even see it like this, right? So this would be the height. This would be that 1, 2, 3, 4, right? So what we want out of it actually is, in terms of the return, what do we want the return of this function to be? We want it to be 1 plus the maximum of whatever came from the left and whatever came from the right, FL and FR, right? So let's look at our code here. So our return value is actually the max of FL and FR, which are the return values coming out from that node. Right, so this is the tree builder. This is like the classic tree builder pattern that we always have, where there's some base case, right? We call it from the left, we call it from the right. Now, we don't always have to call it from the left and right. There are some cases where you only want to traverse right, only want to traverse left, based on some logic that you have. But, you know, in the general case, we want to do some logic based on return value from the left, from the right, and maybe from the node. Right? So like, why would we want to do it from the node? What if we were doing something like, what is the largest node value of this tree? What is the smallest node value of this tree? What is the sum of all the node values of this tree? Sometimes we want all of these nodes to do some logic, right? And then the same with return. And with return, we want this to be a function of all three of these things as well. And here it's 1 plus maximum of what's coming from the left, what's coming from the right. In this problem, we actually don't look at node.value, although, you know, in these examples, it's easy to point out node.value. Okay, so this tree builder pattern, this is basically the skeleton of what we need to code, right? So let's just build this tree builder pattern in a Go function. So we have a Go function here. Imagine it takes a node, and is it going to return a tree node? It's actually going to return a number or an integer, right? Because it's going to return this count. So it turns an int. Which side do I put it on? Do I put it on this side or this side? Is this valid? I'm just going to run this to see if this is valid. Okay, so the return goes before the colon. Perfect. So it's valid syntax, right? So let's think through our tree builder pattern. So If the node is none and we're returning an integer and we're actually taking the heights of these, then what do we want when this 9 is calling both directions? You know, if we have a 9 here and it's calling null and or none and none, what do we want this to return? Well, since we're taking the heights, let's just make this return 0, right? Okay, so we have a from left, we have a from right, we're going to have some logic, and we're going to have a return, right? And this is our base case. And we're going to do this very, very often with many tree problems. So what's from left? So FL is going to be this go function called on node.left. From right is going to be FL or FR, and that's going to be called on node.right. And what is the logic? Well, the logic is going to be, so, you know, oh, I accidentally did that. So the logic is going to be, this is really annoying. The logic is going to be this, right? The height of a binary tree is a binary tree in which the depth of the two subtrees of every node never differ by more than 1, right? So if we have this tree right here, FR and FL are going to give us the heights. So we want to take the difference of it and see if it's more than 1, right? FL minus FR, and see if that's more than 1. So one problem here is that we don't know which one is a larger number, and this is going to make it possibly negative. So we want to take the absolute value of this. And in Python, absolute value is going to be ABS, absolute value. So this is going to be the difference. So if this difference is more than 1, right, then we want to basically get out of this function and return. So should this function be returning an integer or a Boolean? So one way we can do it, it's not the only way, is you have isBalance here. Is balanced in snake case. And we set isBalanced here to false. We return out of this function. We call this, and we return isBalanced in this function. So this is one way. So at any point, if the difference is more than 1, we can return and basically, you know, get out of this recursive call. Okay, so what do we want to return? Upwards, right? We want to return 1 for every height, and we want to return the maximum of the return value of both sides. So this is going to be the FL and the FR, right? And that's going to be, bring it back, that's going to be that from that diagram. So let's check this and see if this works. Gotta make sure you have the word return there. Okay, so we got the wrong answer. Perfect. This will be a teaching case. So the goes 1, 2, 2, 3, 3, null, null, 4, 4. Okay, so let's walk through this and see what happens. So the 4, 4 are going to both return 1 each, right? And then the 3 is going to take the max of those, which is going to be a 1. I'll write this in red. And then the 3 is going to take those and return back a 2. This 3 is going to return a 1. This 2 is going to look at those and it's going to return a 3. This 2 is going to return a 1. And at this point, 3 minus 1 should equal 2. And the diff should be large enough. So why is the diff not large enough? What are the diffs that are being returned? Yeah, so this diff is larger than 1. Right, we have a 2 over here. Is balance result should be set to false. Right there. And it should return and end the iteration. So that should be false. It should be, what we should see is diff2 and then this being false. Okay, that's perfect. And then this return is balance result should, oh, okay. So it's possible it doesn't have mutation rights to that variable. Okay, so yeah, now it has mutation rights to that variable. Let's just get rid of those and submit this and see how it does. I see. So returning out of here is actually not perfect, because if there are many nodes that are parents, then, you know, this actually doesn't. So one thing I can do is if FL is -1 or FR is -1, then I also just want to return out of this computation, because I'm trying to short circuit the computation here, right? All right, 66.37. Thanks a lot. We can go ahead and try to fix this runtime, but thanks a lot. It's been a lot of fun.